Hello and welcome to Minukuu tutorials. In today's tutorial, we're going to discuss regression toward the mean bias in medical research. Even if you're not in the medical research field or in public health field, please never mind. Please stay tuned, and I'm sure by the end of this video, you'll still be able to understand the concept of regression toward the mean bias. Alright, so this is a definition that I took from the internet, from Wikipedia, and I guess you might have probably read this definition. By reading this definition, you might not be able to understand the concept of regression toward the mean, and that's why I decided to make this video to explain to you this particular concept in statistics and how it can affect your research outcomes or the interpretation of your research outcomes if you're not careful about your study methodology, so for the sake of this particular tutorial, I'm going to present a fictive protocol or a research protocol with a diagrammatic presentation that would help you understand regression toward the mean bias or regression toward the mean simply. Alright, so according to this definition, regression toward the mean is a concept that refers to the simple fact that if one sample of a random variable is extreme, the next sampling of the same random variable is likely to be closer to the mean. Okay, like I said, by reading this, you might not still be able to understand the concept. That's why we're going to look at a sample fictive research protocol that would help us understand with the aid of a diagram. Now, but before we proceed, what does this definition imply? What it means is that this phenomenon, or if you want, statistical phenomenon, simply describe the concept whereby an initial value of a particular variable measured within a subject at t0, for instance, increases or decreases after t0 plus 1, for instance. In other words, if, for instance, you measure the blood glucose level of a patient at 9 o'clock, 9 o'clock a.m., there's a higher probability, and for instance, the blood glucose level at 9 o'clock a.m. was, for instance, let's say 1.3. There's a high probability that at, let's say, 9 p.m. this blood glucose level might decrease to 1.1 or even 0.9. If also, or let's say on the other hand, if at 9 a.m. the blood glucose level was lower, for instance, it was 0.9, there's a high probability that at 9 p.m. it might increase to what, 1.3 or something. It might just increase. So if it was lower, then it will be higher after some time. This simple variation is what we refer to as, or fluctuation of a sample value is simply what we refer to as regression toward the mean bias. Now you'd ask me, what's the mean here? The mean here simply refers to generally the standard value of the particular quantity, okay, so or variable. For instance, if we are talking about blood glucose level, what is the threshold? That is the generally accepted mean value within the general population. For instance, for blood glucose level, is 1.1 grams per liter. So because of this variation, the body of the individual will always try to stabilize its glycemic. So if it was higher, the body will try to bring it towards the mean, which is 1.1 gram per liter. So this, and which means, what that means is that the true value of the blood glucose level of the subject cannot just be known. In other words, it can only be estimated to be found within a particular interval, which means any observations that you might take, or if you want any measurements that you might take with regards to blood glucose level on a particular subject at any given point in time, is just the value of the blood glucose level at that time. At another time, it could increase or it could decrease within the same interval. But it always tries to either increase. So if it was far away from the mean, which means it was lower than the mean, which is 1.1 gram per liter, after some time, when you have to take new measurements, it will increase either closer to 1.1 or above 1.1. So the value is always trying to regress towards what? The mean, which is a threshold. Or I hope my explanation is clear. This concept is what we refer to as what? Regression towards the mean. I use blood glucose as an example, but you could use other examples. Alright, so let's look at this fictive research protocol. Okay, it's not a real protocol. So let's assume that the purpose of our study, for instance, is to test the efficacy or the effectiveness of a drug against hyperglycemia. Okay, and now we measure fasting blood sugar of 10 volunteers, and from these 10 volunteers, we're actually going to, like I said, it's a fictive protocol, so we just assume that we have 10 volunteers, and we are going to obtain our sample, our study sample, or our sample population from these 10 volunteers. So, and we are going to actually select the individuals based on this particular threshold, or this generally accepted mean glycemic, or if you want, blood glucose level of 1.1 gram per liter. This was generally accepted. This is a general mean glycemia value. If you want, in the real population, the real world, it's generally accepted that a threshold of 1.1 is the standard mean, or if you want, the general accepted mean glucose level in the human being. Okay, now we are to base our sample selection on this particular threshold, which means all subjects with blood glucose levels greater than 1.1 gram per liter were selected, or will be selected, for our study. Now the selected subjects are given the drug, and then the blood sugar levels are checked again after a few weeks. So this is our protocol. Now we're going to see why is this going to introduce a bias depending on how our study methodology is. Now the primary endpoint is what? The difference between the subject's average blood sugar level before and after treatment. Now you're going to realize that just the mere fact that, we have this kind of variation of blood glucose sugar level within an individual, if at the end of the day, for instance, subjects, the average blood sugar level of the subjects, or if you want, of our study population, that's our sample, if the average blood sugar level of the sample, of all the individuals constituting our sample, was higher, and after some time, due to regression toward the mean bias, it's just probably you to get to understand this properly. Now we have a regression of the mean, like the subjects, the rate, or if you want, the blood glucose level, the average blood glucose level for all the subjects has now decreased. Are we going to say this is due to the drug, or is just due to this probability error, which is based on regression toward the mean bias? So we're going to look at why this can constitute a bias for our research project. Now, to demonstrate this, let's assume we have the blood glucose sugar level in grams per liter, and then the vertical lines that you are seeing represent the threshold of each subject. Like I explained to you, if we want the glycemic of subject number 1, because the glycemic, the value of glycemia, or if you want, of blood glucose sugar level, if you want the value of the blood glucose level of subject number 1, because the blood glucose level usually varies, we can only estimate an interval and say that, okay, all the possible values of blood glucose levels of the subject are found within this interval due to this variability. So it means at 9 o'clock it might be higher, at 2 o'clock it might be lower. So let's assume that at T0, that is before treatment, or before, at the initial point, these are the measurements. So the stars here represent the blood sugar level of each subject at the start point. Okay, so subject number 1, you would see it then, and now you see the star very high compared to subject number 3. That of subject number 2 is extremely high. So you realize that those that are in red represent subjects that are diabetic. When I say diabetic here, I'm referring to just from a clinical point of view. We are not actually basing this diagnostic on a threshold, so we are just basing it on, from a clinical point of view, the subject is actually diabetic, and then those in blue means that they are not diabetic. So let's assume that we fix our threshold to be somewhere here. So our threshold is our general mean, or the general population mean blood glucose level, which is 1.1 gram. This is our threshold. Now, if we are to base on this particular threshold to select our sample, and then remember we said all subjects with blood glucose sugar levels greater than 1.1 will be considered as what? Will be selected to partake in the study, because we assume that they are suffering from hyperglycemia, and then they would take the drug to see whether their blood glucose levels would go down. So it means subject number 1 would not be included, because subject number 1 truly is not diabetic, and the test results have shown that his blood glucose level is below 1.1. As you can see, the star is below 1.1. That was subject number 3, the same, we will not include him. Subject number 7, we will not include him. However, subject number 2 will be included, because the blood sugar level, as you can see, is very high. It's higher than 1.1. Subject number 4 will be included. However, subject number 5 will not be included. Why? Even though he's diabetic, at the time of measurement, his blood sugar level was low, just due to this regression toward the mean, which means that the body would always try to regress this particular parameter or variable towards the mean value, the general mean value, which is, for instance, in our case, 1.1. So imagine somebody, so it means even though subject number 5 is actually diabetic, he's considered as negative, so this is false negative. And then if you should pick subject number 8 and 10, you realize that they are actually false positives. In real sense, they are not diabetic, but at the time of measure, they had very high blood glucose levels. So we are going to select them in the study. So it means subject number 1, 3, 5, 7 and 9 will be excluded from the study. Now, after excluding them, we're gonna now, so this is now our study sample of 5 subjects, okay? Subject number 2, 4, 6, 8, and 10. And before we are actually going to measure the average blood glucose level for all these subjects, and we name that one M1. And then we're going to wait for, let's say, 2 weeks, and we'll come and measure again. We'll try to recheck their blood glucose levels. So now let's assume that we even refuse to give these subjects the treatment, okay? Let's assume we did not even give them any treatment. Based on what I've already explained about regression toward the mean, what that means is that subject number 2, even though he's diabetic with a very high blood glucose level, after some time, there is a high probability that the next time we'll be measuring his blood sugar level, it might decrease towards what? 1.1. If we should pick subject number 8 and 10, you realize that even though their blood glucose level was very high at the initial, like let's say at the initial point, in about 2 weeks time, meanwhile they are not even diabetic, so there's a high probability that their blood sugar levels would stabilize at the next time of measure. That's what I'm trying to say. So let's assume we have these subjects here. This is after 2 weeks. We are going to actually take the measurements again, and let's assume that due to regression toward the mean bias, it means, as you can see, look at what is happening. Subject number 2, even though he's diabetic, initially had a very high value. Now his value is trying to approach the average, which is 1.1. So, so the body is trying to stabilize his blood glucose levels. Subject number 4, it was lower, it has increased the next time. Subject number 6 was lower, now it has gone higher, a bit higher than before. Subject number 8, like I said, they are not suffering from hyperglycemia, or they are not diabetic, but see what happens. So meanwhile, at the initial point of measure, it could be physiological, it could be due to whatever reason, but their fasting blood sugar levels at the time of measure was high. Now you see that this actually proves that they are not actually diabetic. After some time, it has gone down. Now, if we should try to measure the mean again of the new observations or measurements of these 6 subjects, you realize that now the average blood sugar level of these 5 subjects has now decreased. So if you look at M2 compared to M1, M2 is lower than M1. M2 is now even below 1.1, or let's say closer to 1.1, which is the mean. So now the fact that M2 is now closer to, this is what we call regression towards what? The mean. The mean here is 1.1. This is the generally accepted threshold or mean. The generally accepted mean blood sugar level in the real world is 1.1. So you see that when at M1 was very high, now M2 is regressing towards 1.1. This is simply what we refer to as regression towards the mean bias. Now, or if you want, simply this is what we refer to as regression towards the mean. Now, why could this be a bias in your research protocol? What that means is that if you are to carry out a study that is just based on, the simple fact that your study sample was selected on the basis of a threshold, in our case 1.1 gram per liter. So, and then what that means is that, as I explained to you earlier on, what that means is that there's a high probability that if, let's say, subjects because initially some subjects would have very high values, some subjects would have very low values, and the next time you take the measurement, those with high values will try to go down, those with low values will try to go up. Some probably, some would go, there will be some will have a very significant variation when it comes to uh, variation in the particular variable that you want to measure, like subject number 8 and 10. Initially, we know very well that they are not diabetic, but just based on the simple fact that at the time of measure their blood glucose level was risen, we consider them diabetic. Now look at what the results are. When I say diabetic here, I should have said hyperglycemic instead of saying diabetic. But just bear with me. Let's just keep these terms. I hope you understand. When I say diabetic, I just mean that the blood sugar level rose above 1. Let's just pick it that way as a definition for the purpose of this protocol or video. Okay. So now, because of this, like now subjects who let's say 8 and 10 who had very high values have now decreased. They have their blood glucose levels decreasing, and because of this kind of variation, you said those who are actually diabetic, their values haven't decreased nor increased significantly. But those who were not diabetic, but for one reason or the other, their blood glucose levels were risen, you said their blood glucose levels have now gone down significantly, and that would actually, that would actually what shift the mean, which is M2, toward the average or the general population average, which is 1.1. This is simply what we refer to as regression toward the mean. And like I said, this could be a bias in a sense that if you are to carry out a study whereby like you let's say, for instance, let's pick always glycemic. You want to measure you want to evaluate the efficacy of a hypoglycemic drug, or let me just put it that way. Okay, hypoglycemia drug. You want to evaluate its efficacy by giving it to patients with high or hyperglycemia. Now, bear with me that even if you don't administer this drug, there is a high probability that just by the base or by the mere fact or by the virtue of regression towards the mean bias, there's a high probability that the blood glucose level, the average blood glucose level of your study population would decrease. There's a very high probability. So if it was high, there's a high probability that it would decrease. If it was low, there's a high probability that it would increase. And this has nothing to do with probably your drug. So it could mean that your drug is not really efficient. And it also, so right now, if let's say comparing the two graphs before and after, we have realized that if we have to take M2 minus M1 or M1 minus M2, the difference is really significant. The difference, as you can see, is great. And if we have to carry out our statistical test, we might conclude that there's a significant difference between M1 and M2, that is before and after, regardless of whether after 2 weeks we administered the drug or not. So this is what I refer to as regression toward the mean bias. And I wouldn't advise that when you want to evaluate the efficacy of a drug, for instance, you carry out such a protocol whereby you measure the initial values of the variable of interest, then after administering the drug, you measure the value of the same variable after some time. At the end of the day, you cannot conclude whether your outcome is due to regression toward the mean bias or is due to the efficacy of the drug or the non-efficacy of the drug. So in summary, this bias is due to the fact that the sample was selected from the initial group on the basis of a threshold, as with, in our case, 1.1 gram per liter. Because when you select your sample population this way, bear in mind that after measuring their mean, after some time, due to regression towards the bias, subjects who had very high values would try to go down, in that order, and that might shift the mean toward your new observed mean toward what the average standard mean or population mean, which is 1.1. This is simply regression toward the mean bias. Now, you would ask me, how do we prevent this bias? To prevent this bias is very simple. Instead of carrying out, a study whereby, or a protocol whereby you would measure the parameter before the administration of the drug, and after administration of the drug you remeasure that parameter. Instead of doing this, you could just carry out a controlled comparative. And so, just to say, instead of carrying out a before and after study, just carry out rather a controlled comparative study, preferably a randomized controlled trial, for instance. Okay, you could do it with parallel groups, or a crossover protocol. And parallel groups means that you have a group that will receive a placebo, a standard treatment. So you test your new drug against an existing drug, or a standard treatment, or a placebo. You get what I'm saying? Instead of trying to measure, to take initial measurement before the treatment, and after treatment you take the same measurement, you take new measurement on the subjects. Instead of doing this, to prevent this bias, just make sure that you have two separate independent groups. A group that will receive a placebo, for instance, and you test it, and then a group that received the study or the new drug. In case you could also carry out a crossover study whereby each subject will receive both treatments. There is the new treatment followed by the standard treatment, and another group, the standard treatment followed by the new group. So you have two separate groups or study arms to compare, and this would help you actually prevent regression toward the mean bias. Thank you so much for watching, and I hope this video really helped. Please subscribe. Bye.